3-5, written 19 through 22, all and 27 through 51. Oh.
What does WCA stand for?
Written exercise A.
Oh, good.
What are you talking about?
Oh, because we're doing something
What are you talking about? Are we ready?
No. I was so mad at myself. I was at Sammy's house, and it was super shoes on. I was like, oh my god, I'm being Mrs. Joe, do I have to stop?
That's great. Okay, are we ready? I want to give something to you. A is equal to what? Your balance. After what? So many years, correct? P is what? Initial amount invested. R is your, and T is your time. Everything centers around that level of formula because now I'm going to give you something else. Q of T is equal to CERT. I don't like that. For one day?
What is Q?
Really hard. You can even leave tomorrow.
Now, what this means is this Q of T is actually the amount after so many years. The amount or the balance. We're going to go with amount. Okay? Yes. P is your initial, and that replaced with what? C. Well, this is the same concept. Initial amount, instead of invested, it's the initial amount of your matter. Okay? Your isotope. And then R is still R, which is your rate, and T is still time, which is your time. Do we all understand that? Indeed. Flag all in Ed. Another one you might need to know about is Y is equal to A e to the BT. And this, the green one deals with isotopes. The blue one deals with population. So what does Y represent here? This is your Y, but this, instead of the amount, it's going to be amount of your population. Do you like how I'm just adding another color every time? Not beautiful. It's so
It's kind of hard to do that.
I know, isn't that, I thought about that. That's why I said, isn't it nice I'm just adding another color?
Yeah.
Well, I will next slide, okay? P, what's P? The initial amount, which is your C, which is the initial amount of your isotope. So what is replacing P and C? A, this is your initial amount. In other words, when they first started collecting data, what was the first initial amount of the population in that country? Okay? This time, B is your rate. Why they decided to change it to B instead of R, I don't know. Birth rate. I like that. I'll go with that. Good job. That a boy. If I was back there, I'd pat you on the back. Go ahead, Brianna.
You can give me bonus points.
Or not. And T is still your time. Do we all understand that? Yes or no? Okay. Why we decide to change up this formula so much with our little PERT? I don't know. Just roll with it, though. It's a very easy concept. You hear what I'm saying?
I'm picking up what you're doing.
You are picking up when I turn it down.
Yes, making a mess.
Okay, page 225, folks.
Oh, hold up.
Whoa.
Slow down, they can't pick up what you're trying to
Apparently.
Hold up, why?
They need to drop what they have in their hands so they can pick up what I'm throwing next. Drop like What? No. I'm sorry.
Yeah, me too. But,
No, I don't have
on, how much do you get?
Well, I'm not looking forward.
People,
Oh, yellow.
hurt is continuously compounded. And you're going to use this for problem 15 on Friday's homework. The other formula you need this is the compounded n times a year. And you'll locate that on page 182. Is that what I said? I am. Page 182. You're going to use that for problem 16.
Oh, that's fine. Hold on.
Unbeat always. Don't I? Have nice.
What is N for?
Am I going to have time to what?
No, question about Friday's homework. No.
What questions do you have about Friday?
Like the logic and, well,
I think it's like, I can never
because I put it down here for like 11.
Hey, if I'm answering questions over that, that means you're going to have less time for me to do today's homework. Okay. Moving swiftly along. The initial, which is your P, was going to be 500. I do not know my rate, and I do not know my time to double. Y'all need to zip it. And then the last one would be amount after 10 years. And that was 1292.85. Okay, in order to find all this out, what do you have to have? Okay, you have to have this formula. The amount that I have after 10 years is $1,292.85. The initial amount that I put in was 500. My rate, I do not know, but that time that it took for that to get to $1,292 was 10 years. True statement? Now I can find my rate, and after I find my rate, what can I find next? Time to double. Do you understand that? It's all a matter of which one do you find first. Number 10? I'm not going to finish this. Are you good, Steven?
Yeah.
Okay. Number 10. P is going to be 10,000. My rate, I do not know. My time to double was 12 years. And my amount after 10 years, do I know it? Okay, so with that said, again, what am I given? I got to use what I got. What I have is my time to double. So 2P is equal to PERT. Remember the P's cancel out. So 2 is equal to e to the RT. How long did it take it to double? 12 years. So now the natural log of 2 is equal to 12R. So then the natural log of 2 divided by 12 is equal to R. That's your rate. Now that you have your rate, can you find the rest? Brianna, are we good? We good on last night's homework now? Anyone? Going once? Going twice? Gone. Moving right along. Now, just like our doubling, for 19 through 22, it says in exercise 19 through 22, complete the table for the radioactive isotope. So radioactive isotope says you're dealing with which formula? CERT is what you're dealing with. Now, what information do they give you? They give you half-life. Now, that means if I'm talking about half-life, it's the same concept of saying I want half the amount that I started with. True statement? I started with C amount. Now I want to get half of that. So what happens to the C's? Little cancelage going on there. So half is equal to e to the RT. This will be your half-life formula. Do we all understand that, yay or nay? It's just like you're doubling and you're tripling your money. True statement? Chair down. Thank you. So with that said, number 19. The half-life is 1,600 years, the initial quantity was 10 grams, and the amount after 1,000 years is what we need to find. Now, folks, think about that a little bit. I have 10 grams. Half-life means how many grams should I have? 5 grams. And how many years did it take me to get to 5 grams? Yeah, you do. So I had 10 grams. I gave you 10 grams of radioactivity and you buried it somewhere. Okay? You with me? And it took 1,600 years before it actually went down to half the amount. You with me? And that is 5 grams left whenever it's half the amount after 1,600 years. Now here's my question for you. I need to find out how much I'm going to have after 1,000 years. What type of number are you expecting to get there?
About 7.5. 7 or 7.5.
Why is it bigger, Whitmer? Because 1,600 years says it's going to have to be down to 5. I'm only going 1,000 years, which means it has to be greater than 5, but less than 10, because it cannot be more than what I initially buried. True statement? I would say it's between 5 and 7. Do we all get that? True statement? Okay. So with that said, I want you to think about that. Is the answer that you're about to get, is it even logical? Does it make sense? Do you understand what I'm saying? So with that said, let's go ahead and use our half-life formula. Okay? Half is equal to ERT. In order for me to do this, I have to be able to find the rate at which my lovely little radioactive material is actually decaying. So how many years did it take for it to decay that far? 1,600. True statement? So 1/2 is equal to, the natural log of 1/2 is equal to 1,600 R. Now what? Divide by 1,600. And natural log of 1/2 divided by 1,600 is equal to your rate. Now, with that said, are we all paying attention here? These need to go away. And that's what I want. So, I'm going to Control W this. Now, I'm going to get a new document up. I need it to be a calculator page, and I'm simply going to do my work on my calculator. Okay, so I'm going to have the natural log of 0.5, arrow to the right, divided by 1,600. Hit enter. Do you see your rate there? It is very, 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 very important. Now, you keep your rate just like it is on there. Because if I round up to 3 decimal places, what's it going to be? 0. Now, I'm pretty sure that it is decaying. It's just decaying at an unbelievably snail rate, swap rate times 15 million, right? So it's a very, very slow rate. We just have to deal with that. So I'm going to have negative 0.000433 is equal to my rate. Now, why is that number significant? That's the rate, but why do I need the rate? Because that has nothing to do with what the problem asked me to find. What the problem asked me to find was the amount after 1,000 years.
That's how that rate is decreasing.
I need to know how fast this thing is decaying so that I can then go right back to the lovely little Q of T is equal to search and plug in the values that I initially were given. 10 was my initial value. My rate is that negative 0.00043443. And that's going to be times 1,000. Do we all see that? Now, how do I do that on my calculator? Watch. Okay? 10, E, arrow up. Go get that and hit enter. Times 1,000. Why does my rate look different than what it is up there?
Just
Not just because because it's in scientific notation. The calculator's putting in scientific notation so it can calculate easier. And what is my amount after 1,000 years that's in my container of my isotope? About 6.48. That's how much is left. Do we understand how to do 19? Make sense? We good? Moving smartly along. 20. Same concept. Number 20, they give you the half-life and then they ask for the initial, but they give you the amount after 1,000 years. So has anything changed here really? What do I have to find first? The rate. Now folks, I'm going to cheat a little bit here because 1/2 is equal to e to the RT, and I know that my t is what value? 1,600, so I know what my rate is already. I know that's cheating, but since you used it from the last problem, it's dumb if you don't use it, correct? So I know what my rate is because I used it on the I found it on the last problem. Now, I need to know what now? What I started with. So I'm going to come right back over here and use my lovely little formula. Q of t is equal to cert. And my Q of t is my quantity after how many years? Q of t is going to be the 1.5. C we don't know. My rate is this junk number. And t is going to be 1,000. Do we all see that, yes or no? So, this is just a number because it's e to that junk. So I'm going to divide both sides by that. And that's going to give me my C value. So I come back over here, and I'm going to take, I can't remember where we go, 1.5. 1.5 divided by E raised to my lovely little rate up here. I'm going to grab it, times 1,000. And hit enter. Now, when you hit enter, you want to make sure that you have entered in your equation correctly. Make sure that's what you wanted on your paper. And what is my amount after my initial amount? 2.31. 2.31 is my initial amount that I started with my isotopes. Do we all understand that from 19 through 22? Excellent. Moving right along. Please go back. Please go back. We good? We good now? Oh, don't laugh whenever you're sitting there talking too. Okay, 27. The table shows the population of millions of 5 countries in 2000 and the projected population of millions for the year 2010. So we have 5 countries. Australia, Canada, Philippines, South Africa, and Turkey. Now, it says find the exponential growth of the K model, y equals a e to the bt, or y equals a e to the negative bt. What's the difference between the two formulas? So what's the difference? I understand the negative is the difference. What's the negative mean?
One's increasing, one's decreasing.
This is an increasing, meaning you have a lot of births. This is decreasing, mean what? You have a lot of deaths. The death rate is high. Okay? Don't say that. What?
Oh, I said that baby's saying.
I don't like that. Irritating. It keeps something hard at you. Okay, now, they give you that population at 2000 for Australia, it was 19.2 million. In 2010, we had 20.9 million. 20.9 million. Now you guys tell me, whenever you're given data like this, what should your brain immediately transfer the data into? Not a calculator. So, your attention span is that a gnat span, you need to pull it together and pay attention. When you see this, your brain needs to say, oh, well, that's actually a point. Because instead of the directions to let t equals 0 be 2010, which means that would be my initial value. Because that's the first point they gave me information on, was year 2000. Which means year 2010 would represent what number? 10, and that would be 20.9. Now, I want your brain to transfer this into points so that you can know that you can graph it. However, we're not graphing these right now. I did that because later on, whenever we have other problems, you're going to need to get that point out of there. Now, what your brain really needs to get is this formula. I know it's increasing, so I have to use the positive birth rate, correct? Now, with that said, what does the y represent again? Y is the amount after t years. What does the A represent? Is the initial amount. And what is that amount here? What is that amount? 19.2. Very good. And what does B represent? The rate. Do I know that? And what does the T represent? And what is my T? 10 years. And after 10 years, what is my Y? 20.9. Do we all understand what I did there? I took every one of my letters, I wrote down what it represented, and I wrote down the meaning of it. Do we all understand that? Okay? Because now, I'm going to use that formula to do what? I'm going to use that formula to find my lovely little rate. So y is going to be equal to 20.9, A is 19.2, B we don't know, but the time that it was there was 10 years. Do we all understand that, yes or no? So this is going to be 20.9 divided by 19.2 is equal to e to the 10b. Now what? Natural log, natural log. Yes? And then divide by 10. When you divide by 10, that's the same thing as multiplying by 1/10. Why am I doing that? Because it looks really ugly to have a fraction over a fraction. So now I come over to my calculator, I'm going to plug that in. Control division key gives me the 1 over the 10. Times the natural log of 20.9 over 19.2 and hit enter. What is that? That's my rate. That is my rate at which my births are increasing. Do we all understand that? So my B is going to be so there's my B value. Now what do I do? Why did I have to find my B value? It says use the model to predict the population of each country in 2030.
Now you have the rates.
Now I have the rates, so now I can come right back up here and I can say, ooh, I need Q, nope, I need Y. Y I don't know. A is my 19.2. E raised to the 0.00848, and that's going to be in year 30. Do we understand that? Because what is 30 representing? Year 2030. So if I come over here and actually type that in, 19.2 times E arrow up and get that lovely little rate, times it by 30, and hit enter. What's my population in the year 2030 for Australia? 24.76.
9 makes it 45.
Yeah, we're not rounding that far.
Whoa. On the Pharisees.
Huh?
On the Pharisees.
On Pharisees?
Yes, on the Pharisees.
I like them. Makes my world go round.
So this is for Australia.
That is for Australia. Now, you still have to do Canada, Philippines, South Africa, and Turkey.
Oh, that's a cool.
Are we whining?
Yeah, I was asking if that was a problem.
Yes.
We're still gonna do T.
You have to find the rate. You have to find the rate for each one because they are different. Their populations are different. Some of them might be declining, so the rate can be negative. Like people are dying in South Africa, so you gotta make sure that you use negative.
True.
That's not funny. I don't care who you are. That's not funny. Okay, problem 31. It's the same as 19 through 22. It's your isotope problem. Problem 33. Problem 33. A sport utility SUV that has cost $32,000 new has a book value of $18,000 after 2 years. So again, what did they give you? They gave you points, right? And with that said, what is my initial? My initial is 32,000. Do we all understand that? My initial is 32,000. What's my time? Is 2. And what is my amount after 2 years? 18,000. Now what are you missing there? Your rate. So you can get an exponential function out of that, can't you? Okay? Now let's read part A. It says find the linear model B equals MT plus B. Linear model means what, folks? Linear model means I have V is equal to MT plus B. B is your Y values, just to make sure you're aware of that. M is still your slope. T is your X values. And B is your y-intercept. Now, if I need to find the slope of a line, what do I do? Slope is y2 minus y1 over x2 minus x1. Here's x1, here's y1, here's x2, here's y2. Do we see that, yes or no?
Yes, I do.
So this is going to be 32,000 minus 18,000. And actually, I'm going to relabel these. Just because it makes it easier whenever you do your math. 32,000 minus 18,000 all over 0 minus 2. So what's 32 minus 18? So this is going to be 14,000 minus 2, which is going to be negative 7,000. Why is my slope negative? Because the price of the car is declining in value. If your slope wouldn't be negative, then you'd have an issue, correct? Okay, so now I know what my slope is. Now how do I find my B value? My B value is my y-intercept. By definition, what is that? The point on the graph where it touches the y-axis, which means your x value will be, hello? Don't I already have it? Yes? So B is 32,000. So V is equal to negative 7,000 T plus 32,000. That is my equation. That's part A. Now what's part B say to do? Find the exponential. Exponential y is equal to a e to the RT. What's y again? We have it up here. It's the amount after how many years? It's 18,000 after 2 years. So this is 18,000. My initial would be what? 32,000. My rate, I don't know. And my time would have been 2 years. Can you find your rate and then come up with the equation now? Yeah? All right, we're out of time. You guys all understand what you need to do to teach this problem out? Maybe.
We'll find out tomorrow.
We'll find out.
We'll find out sometime in the.
All righty. You want those notes?
Whether I